Back in the mid-1800s, an English mathematician named George Boole determined that math and logic actually went hand in hand. And to take it a step further, that all logic boiled down to two conditions, true and false. You may have already learned about how to use Boolean operators in your web searches to make them more effective. You may have used and, or not. In this lesson, you'll learn how to take some very complex, even nested statements and boil them down into true or false. In the last lesson, we took a look at how selection works conceptually and in pseudocode. You were able to see some Scratch, but in this lesson, you will actually use Scratch to see how selection works in a program. You'll especially see when programming in this lesson that selection statements help the computer to make a decision, hopefully the right decision. So here on the screen on the left, you'll see an example of one type of selection block. Here's our if, then. And of course, we said that in the pseudocode, you don't see the word then necessarily, but they do give it to us in Scratch, so that's kind of nice. So we have our if, and of course, hopefully you remember that this empty hexagon is the condition. So you'll remember that on the AP exam in the pseudocode, you might see something where condition is in parentheses instead of a hexagon. And of course, in the actual block pseudocode, it is an oval. All right, over on the right, we see what we can call a command, a statement, and specifically it's an imperative statement. It's a command for the sprite to move 10 steps, and that's our instruction block. And of course, we can pretty much see where we're going with this on how the instruction block fits into the if-then structure. The most basic type of conditional block is the if block. We looked at a couple of the other ones, and we definitely saw that the if structure was shorter. Sometimes computer scientists will refer to this type of structure as branching. And based on the fact that we can see this, this arrow, it does look like there's a branch coming off of the main flow of the program. So consider a basic computer program like the ones that we've written up until now. Essentially, we have a sequence of instructions, and the computer executes one instruction, then moves on to the next, and the next, and the next. And we have an arrow that shows us the flow of the program, and the arrow just continues moving from one instruction to the next. Notice that the if block resides in the control tab. And that's key because all of these structures deal with the flow control. All right, the if block, rather than over on the left where we see just a sequence of instructions, the if block represents a choice or a decision. So if some condition occurs, then the flow actually will branch off instead of just, moving from here to here. It's going to actually branch off to that instruction and execute that instruction. So in this particular case, the control flow branches off based on whether or not the sprite is touching the edge of the screen. Maybe that's like the mud pit or something like that. So if the condition does occur, then the sprite slows down its speed. If the condition does not occur, then the program simply moves on to the next instruction. Scratch allows for a really easy visualization of which blocks are included in the if statement. So any block inside that little, I don't know, sometimes kids tell me that this looks like an alligator mouth or something like that. So, if the statements are inside of that structure, then clearly they will be included if the condition is met. And of course, if the condition is not met, they are simply skipped over. And so this is why it's sometimes called branching, because the flow grows a branch, or an arrow in this case. What kinds of conditions can we use in a program? In the last lesson, we did talk about a variety of different conditions, but we're going to use the term binary conditions. And those are conditions with only two possible outcomes. Either the condition is met, and it's true, or the condition is not met, and it is false. So much like other aspects of computer science, it boils down to a binary bit, a dichotomy, a yes or no, an on or off, a true or false. Conditions must be formatted that way. Scratch encodes these Booleans, these binary values, as hexagons. And that's the shape for an empty if or if-else statement is that empty hexagon, and it can be filled by a hexagon. If you try to fill it with some other value, like an oval, it won't work because an oval is simply a value. It is not true or false. There are many valid hexagon-shaped blocks that can fill that hole. So let's just take a look at these in particular. So the first one is from the Sensing tab, and that's why it's blue. And it's the sprite being able to sense its environment, and in this case, being able to tell whether or not it is touching a color. Then from the green palette, we have operators. Of course, operators are green. And the operators tab has arithmetic things such as add, subtract, multiply, divide, so you can actually perform mathematical operations, but you can also use the relational and Boolean operators like we talked about in the previous slideshow, and these come out to a true or false value. They don't actually perform an operation, they simply compare two values and come out with a true or false. The third one, you can see that here's a nesting situation. Multiple operators have been used to define a condition that's a little more complex. So there's nothing to prevent the condition. If you remember, I talked a little bit about George Boole, and he was a philosopher and a mathematician, and he thought about really, really complicated things and determined that everything can be boiled down to true or false. So no matter how complex a condition you set up, so for example, this one requires that the speed be less than 3 and greater than 5, unless there's a decimal value involved. But no matter how complex this operator is and how many times you've got nested operators within nested operators, it's still going to boil down to true or false. So you're going to have an opportunity to explore an existing Scratch program that uses if statements to determine how many days are in a month. And there are a lot of new things in this program that you might not have seen before, so be sure to explore. Remember that when you open the program, you can click the button that says See Inside, and you can go in and see the code. You can remix if you'd like, you can play around with it, and you won't ruin the original program. And it's going to add to your understanding of basic code and blocks and their combination because it is very complex. So up until now, our blocks have been analogous to light switches. So when you turn a light switch on, the lights go on, that's what happens. And when you flip the switch to off, they actually turn off, and something does not occur. So it makes sense, given the nature of our conditions, that they are binary, on or off. And that, of course, remember, that goes all the way down into the tiny individual circuits in your processor, which can be either on or off, not like partially on or a little bit off. It's just two states, on or off. And there's a little fake Scratch block that's showing this. If some condition, here's a green operator, then do something, right? So we know that that illustrates the concept. However, this is not the only kind of binary switch that we can model in a program. We could actually ask our program to literally switch to another path, right? To take one path over another, similar to a train switching tracks. Once a train switches tracks, it is no longer on both tracks and it's not going back to the other track. With this type of switch, rather than choosing to do something or not, you're actually choosing which of two possible options to go with. And only one of the outcomes will ever happen. The train can only take one track. Scratch allows for this type of conditional with the if-else block. You can check the condition, check and see. It's going to evaluate to either true or false. You can do something if it is true. In this case, this one right here is the thing that would happen. And that's exactly the same as a standard if block. However, if the condition is not met, you can actually go in and take a completely different path, okay? The else. And if the condition is false, it's going to do what is in that enclosed portion, right? And this is different from the standard if block. Instead of doing nothing if the condition is false, we actually specify what to do, all right? And over here, we can see the direction of flow. So, we start here at point A, And then our program is either going to go to point B or it is going to point C. And if it goes to point C, it will never reach point B. And likewise, if it goes to point B, it will never reach point C. So we have completely changed the direction of flow based on whether the condition was met or not at A. So to recap, the if versus the if else. Questions to think about. What functionality does else provide that the if did not account for alone? All right, so we said a couple slides ago, we said that the if is simply you either do this or you don't, all right? And if you don't do it, you just move on to what's next and you kind of stay on the same path. You branch out if it's true and then get back to the regular flow. The if else, remember, we actually provided for two possible paths, all right? So you can imagine that that would be very useful in programming. You know, sometimes it is appropriate to simply ask if something is true and to do something if it is, and then just continue on with the program. But sometimes that condition being true or false dictates that you need to take two completely different paths. So it's very useful. And the second question there, in the case of a plain if block, if the condition is not met, the code contained in that block is just skipped. So how does the addition of an else change that behavior? Well, the answer to that was kind of encapsulated in the answer to the previous question. The else allows for the program to completely change the direction of the flow, to go left instead of right, if you remember the little graphic, and to make sure that it will be two distinct possible paths that the program can take in terms of the flow of logic. I've used this word a couple of times when talking about operators, where we nested a couple of operators together. But the word nesting actually applies to an even bigger concept. What do you think would occur if an if block were contained in another if block? All right, so when an if block is nested into another if else block, we call that a nested block. And on the screen, you can see the examples. So you can see in the Scratch example, we have our good old ask and answer. So we're asking a question. We can see that the main structure is right here. Okay, if, and the condition is answer less than 1, we're going to do this. Otherwise, we're going to do this. All right, that's what we want to focus in on. So this inner part right here is the instructions for what to do if the condition is not met. But if the condition is not met, we actually have another situation to check for. All right, another condition that we want to check because there are actually 3 different things that could possibly happen. That is the usefulness of nesting if blocks together. I'll show you my age and tell you that I'm a child of the 70s and I watched a lot of Sesame Street as a child. There was this amazing animation of these Russian nesting dolls. It was amazing. You should look it up on YouTube if you get a chance. But that's what you need to think about when you think of nesting. So one control structure completely nested inside another to allow for not 1, not 2, but 3 possible outcomes. Okay, so in this particular nested situation, the first outcome would be to say, oh, you're an only child. And that's it. It would skip to whatever comes next down here. But if that wasn't true, then it would move on to here and it would ask a new question. And then based on that answer, it might say, awesome, I have a brother too. And if it does, then it's done, moves on to back down here. And finally, if none of those 2 conditions were met, then it would execute this line right here, right? So it's interesting, and I guess it gets a little complicated to look at, but you can see it's very useful when there are multiple choices, not just 1 or 2. So why do we need nesting? Well, we need nesting in cases where there are multiple choices, right? So, and we just talked about that. So on the left over here, if there were only one choice, one option would be to ask, are you thirsty? And then you could give either a yes or no answer. But If the answer is yes, then there's actually more work to be done because now we need to move over here. If the answer is yes, then we need to check and see, well, what would you like to drink to quench your thirst? And in general, there usually are more than 2 possible outcomes. And that's really why we need to use nesting. Next, you are going to have the opportunity to try out nesting on your own. What you're going to do is the try it out exercise. You are going to model the sample nested blocks, the ones that are there in the lesson for you, in your own Scratch program. And you're going to run them and see what happens. And then you're even going to modify them a step further. As a hint, you might need to add another nested if statement or if else. And just remember to keep straight which instruction belongs with which condition being met or not met. Have fun.